All right, thank you very much. Hi, everyone. My name is David Hoerster. I'm a product manager here on the Sentinel team. And as it was said, we're going to talk about, as the title says, transforming data collection for AI-ready security operations, Microsoft Sentinel. So what does that mean? Really, over the last year, there's been quite an evolution of Sentinel. The SIM is still the SIM that you know and love. You're ingesting data in using the different types of ingestion methods. But we've introduced some additional components to Sentinel, namely the platform comprising the lake and graph and MCP. And some people might say, well, how can I really ingest data in a AI ready Sentinel? So what we're going to do today is go through the different log ingestion methods, talk about some of the newer features, and just really help you understand how you can start to bring data in the Microsoft Sentinel and really get the best use out of your data. So we have a jam-packed agenda today, so and only an hour to get it in. So we're going to move a little fast. So I'm going to talk about just the general overview of the log ingestion methods and talk about the data collection pipeline, in a general way. I'm going to turn things over to my good friend Javier. He'll talk about table management and our on-prem connectors. And then we'll let Sagar bring things home with first-party connectors, third-party data collection, and normalization. All right, so let's just kind of do a quick overview of Sentinel platform and the ingestion methods. So if you think back a year ago, Sentinel was really just this SIM box, right? So Sentinel SIM is today still the same SIM that you know and love, with additional features, but the data is still being collected through the log ingestion methods that you're probably familiar with. Sentinel platform has been introduced over the past year, and that's really comprising this bottom section of this diagram. With the data lake really being the backbone of the platform, really forms the overall foundation for the platform. And that really helps to enable additional modalities like Sentinel Graph that you may have heard of, and also MCP server. So as data in the SIM layer can be ingested, using a number of different methods, such as our extensive connector framework, the data can also be ingested into the lake via a couple different ways, either through mirroring of data that's being ingested through the SIM tier, or the analytics tiers, we'll call it. And that, as that data gets ingested into the analytics tier, it gets mirrored down into the data lake. But you can also set up those same connectors that you set up in the SIM tier to ingest data directly into the data lake. And we'll talk about that, that direct ingest capability, or being able to, or actually really having that capability of mirroring of data that's going into the analytics tier, or changing where you want that data to come in using direct ingest. Excuse me. We'll talk about that when we talk about table management in a couple sections. But the ingestion methods we're going to talk about next will work whether the data is being ingested into the analytics tier and mirrored down, or directly into the data lake directly. So let's talk about our different data ingestion methods. All right, so right now I'm showing a single Sentinel icon, but all the ingestion methods we're going to talk about will support both analytics and data lake tier ingest, as long as they're using the data collection rules style of ingestion. And that's really the majority of cases. In this case here, we see a Microsoft Entra ID tenant and a Sentinel workspace contained within it. Now that Sentinel workspace looks a little lonely, so I think it needs a little bit of company. So let's talk about our first party connectors. Now the first party connector family, really these are the security and management type of tools that you're very familiar with. And those connectors can be ingested directly into Sentinel. And we'll talk about first party connectors in a couple sections. If we take a look at expanding this a bit, there's a couple different types of additional connectors that are available. We have diagnostic logs, and that's really being mainly used for Azure resources and services such as like Azure SQL, Azure Firewall, and also some Entra ID logs. We also have a dedicated SAP suite of connectors, so You can ingest SAP information directly into your Sentinel workspace. You can install an agent on your Azure VMs to send data directly into your Sentinel workspace. And then we also have the codeless connector framework, or CCF, or the REST API. Really is like the log ingestion API that we'll talk about in a little bit. And I'll show a quick example of log ingestion API in a couple slides. Expanding upon this, from the CCF is really used to support a large number of third-party, partner, and ISV solutions that are listed here, and many more. And these solutions, these connectors are all published in the Content Hub that you can access. So this is kind of one half of the equation, but then what's really kind of missing is sort of our on-prem solution. And here there's a lot of different ways that you can send data into your Sentinel workspace. So if we look at the Linux world, logs like syslog, ceph, and custom logs, there's several alternatives to send that data into your Sentinel environment. You can have Azure, the Azure Monitor agent. So you can have that agent installed, and you can send logs from syslog or ceph sources directly into the Sentinel workspace. If you're using things like Logstash, Cribble, Databon, you can also and you can send those logs also. We support that, sending that into the Sentinel workspace. And then also the Azure Monitor pipeline is great. It's getting a lot of attention, and it's really great for those high ingest scale capability situations for your syslog and ceph sources, and we'll have a little section talking about that too in a little bit. So that's the Linux side of the equation. If we take a look at the Windows side, we also have the Azure Monitor agent for Windows servers. So you can install that on your VM or on your machines and send that data into the Sentinel workspace. You could also centralize, if you have a number of Windows servers and you want to be able to centralize the collection of those logs, you can set up a Windows event forwarding policy and then have those different Windows servers all send to that or through a subscription through that policy up into the Sentinel workspace. And if those servers can't connect to the public internet, you could also set up a log analytics gateway in order to send that data into the Sentinel workspace. And then kind of moving over to the far right, for the IoT space, Defender for IoT, that connector is also available to be able to send your information, your log information into the Sentinel workspace. And then last but not least, if you're building custom applications, again, you can take advantage of that REST API, that log ingestion API, to be able to send your logs using a number of the different SDKs that we have available, such as C#, Python, Java, and on, to be able to send, again, that data directly into the Sentinel workspace. And we'll actually take a look at I have a very simple example of using the log ingestion API to be able to send data up into your workspace. All right, so moving on, let's take a little higher level view of the data collection pipeline and see how this is all working. So thinking about all the different log ingestion methods, if we kind of take a step back, essentially those are all really clients of sending data into your Sentinel workspace. So those clients could be whether it's going in through direct ingest or some form of an agent being able to send data eventually into your Microsoft Sentinel workspace. So really this data collection process is all supported by the data collection rules, and we'll call those DCRs. That provides a common processing path for your incoming data. So each scenario that you have around data collection can be defined within a DCR. You can think of a DCR essentially as a configuration file, right? And that configuration file provides instructions on how your data should, or how Sentinel should be processing the data that it's receiving. So depending on the scenario, your data collection rules can specify some or all of this information. What kind of data am I going to be collecting? What's that schema of that incoming data? What types of transformations do I need to apply to that data? and we have a few of those listed here. Then lastly, where's the destination? Where's that data going? Once it's processed, is it going to an analytics workspace and potentially even other destinations like event hubs and storage? So at a really high level, that's how this flow all works, and it's provides a lot of benefits. So what might those benefits be? Essentially that flexibility, right? As we saw with the different log ingestion methods, we're ingesting data from a lot of different places, and essentially we're using the same process, the same flow to be able to handle all that data coming in from different sources, what's coming in from applications, services, devices, whatnot. Again, the overall control is that the DCR provides, being able to define the schema, the transformation, and the routing, essentially all in a configuration. That means the code, if you're actually building the application that's going to be sending log information eventually over to Sentinel, it doesn't really need to worry about that. It just needs to know where am I sending the data. And your back end tables really don't care. They're just receiving that data. The configuration in the middle really is doing all that work for you. That's really this last benefit here. That DCR provides that abstraction layer between the source and the destination. So your source and your destination stay pretty pure. The configuration itself is really doing a lot of that routing and the key transformation type of work. And then also, that integration capability, right? I want to be able to receive logs maybe from other SIMs, other observability tools. That DCR type of data process flow really excels at allowing you to achieve that type of process. All right, let's just hit on a couple quick key concepts. So DCRs and DCEs, lots of acronyms. So a DCR, as we've said, is a data collection rule. And really, it's, as we already said, it's defining how that data is being transformed, where it's going. It's defining the shape of that data and any kind of filtering logic. It's defining those destinations, whether it's a log analytics workspace, Sentinel, storage, or event hubs. Another key concept really comes into play specifically if you really are doing really secure transmissions of data, especially if you're using private link. So private link is going to be required, DCE is going to be required if you're using private link. It really just acts as a very secure ingestion gateway, and it's very much region-specific endpoint for receiving those logs. If you're not using private link, you can generally think of that DCE as being optional. And in the log ingestion API sample I'm going to show, I haven't provisioned a DCE for that. There's a couple different DCR types that we can work with. The direct ingestion type of DCR is really the one where if I'm running my own custom application, I'm going to interact specifically with one DCR. Connectors can also do direct ingest also. But again, it's the application is sending data to the API endpoint that's specified by that DCR. And again, the DCR is specifying the structure, transformation, and the destination. I can have DCR associations, and so that really allows you to kind of reuse and create strategies around when I have a many-to-many relationship. I have multiple DCRs. I could potentially have multiple clients. And I want to be able to say this particular client's going to send data, and I want it to be processed by multiple DCRs. Or I could say I have multiple clients that are all going to be using the same DCR. So I can create that association between the clients and the DCRs to be able to kind of create a pretty interesting man-to-man relationship there. And then lastly, and this is a little bit more on the legacy side, but if you are doing any sort of collections that aren't using specific DCRs, I can create a workspace transformation. That's really applied at the overall log analytics workspace level, and there's only one workspace transformation available per workspace. So it's more of like a generic type of transformation that can be applied if there's not already a DCR that's being invoked when you're sending data in. All right, so let's take a real quick look at using DCRs and and being able to ingest data into a workspace using the log ingestion API. So I have a couple really simple applications that all they're doing is just sending data, some really simple sample data into a workspace, but just to kind of illustrate what that code might look like. So from a prereq perspective, all I'm really using is I have an Azure subscription already available. I have a log analytics workspace. In my case here, it's not attached, or it's not set up for Sentinel, so it's just a plain old log analytics workspace. And you would just need some familiarity either with Azure CLI or REST APIs. In this case here, I'm using C# and I also have a Python example. The setup steps are pretty straightforward. I've already set up an Enter ID app registration. I've created a new custom table in my analytics workspace. I didn't have to apply or deploy a DCE because I'm not using private link. So I've created that DCR, that configuration, and really it's just defining, for the most part, the schema and the destination, which would be my custom table. And I've associated an Enter ID app role so that it can write to that custom table. It's just a monitoring publisher role. And then I'm going to use two different languages, C# and Python, using the log ingestion API, essentially to send those logs via a post to my workspace. So let's do a real quick demo and just see kind of what this looks like under the hood. So if I bring up VS Code, and again, I'm going to go through this pretty quick, but from a C# perspective, what I'm doing first is I'm setting up my endpoint information. So I'm not going to show that, but essentially it's what's the URL, and there's an immutable ID that are associated when I set up my DCR. So I'm just setting those up in variables. And the stream name is actually the name of really the destination of where I'm sending my data. And so in this case here, I'm just calling it my table raw data. I'm instantiating the log ingestion client. So that's part of the C# SDK for the log ingestion API. I'm creating a binary data object. This just represents my JSON data that I want to send over to my log analytics workspace. I take that binary data. Essentially, I'm serializing it over into a memory stream. I'm going to compress it using gzip. And then at that point here, I'm going to call upload async, which is another method off the log ingestion API, stating what's the rule ID that I'm sending it to, and that's really the destination, the endpoint of the DCR, and that was part of the sensitive information up on top. What's the name of the stream? That was at my custom table raw data. And then here's the content of my request, which is the gzipped, the compressed bytes. And essentially, I'm just doing an async call on this, and I get back a success. So I could run this pretty quick, and nothing coming back should indicate everything worked great, and it looks like it worked great. All right, so I'm going to hold on checking the log while I take a look at my Python sample. So if we wanted to take a look at what Python would look like in that case, I'm much more of a C# person, so this actually makes me a little sad that this is much more terse than .NET. So it's a pretty simple, straightforward kind of call. So I'm basically creating an instance of the log ingestion client that the log ingestion API provides for Python. Here's my body of the message that I want to send over to my workspace. And then essentially all I'm doing is I'm calling upload on that client class instance, sending in the role ID again, basically the same information that I sent using the .NET example. Here's the stream, which is essentially just the compressed version of that JSON value. The name of the stream that I'm sending it to, and then the body, which is just this JSON object. So again, pretty simple, straightforward kind of stuff. Hopefully that works. It looks like it did. So now we can go over to my workspace, take a look at what came through. And as you can see, this should all run. And the computer 1s and 2s, this is actually coming from the C# example. Computer 100 is coming from Python. But you can see that even though I'm sending in JSON data, I can actually send it in a fairly nested type of structure. So I'm able to retain that in my workspace log. But hopefully that gives you a really quick view of how I can take advantage of the log ingestion API to send data into a log analytics workspace, and really just provides you an overview in general of the different ingestion methods that are available to be able to bring data in. And we're going to go through those methods in more detail next, and then a high-level view of the data processing pipeline. So with that, I'm turning things over to Javier, and he's going to start talking about table management. Take it away, Javier.
Perfect, David. Thank you so much. So hello, everyone. Let's talk about table management. But before we go there, I wanted to make sure that we understand how things work when you have onboarded into the data lake. And this is why we have this slide that explains basically the different flows that we have when we have a workspace that is data lake enabled. So first of all, we have our data sources, right? That, as you normally have been doing, are ingested into the analytics tier using the different methods that we know that David explained and the API that David explained. This allows you to benefit from all the different features that are in analytics, like detections, hunting queries, workbooks, and so on. Once you enable the data lake, there's one thing that happens at the beginning, which is that data ingested into analytics, it's automatically mirrored to the data lake at no additional cost. Okay. So that's the first thing, and the data gets populated in the data lake. But if you don't want to send your data into analytics tier, because maybe it's a huge volume of data that doesn't have that much security value, you can always just send directly the data into data lake, right? So as you can see, data can be sent directly into the tier of the data lake. And then once the data is there in the data lake, you have several options to basically interact with the data. You can use KQL jobs. So KQL jobs allow you to use full KQL. You can do joins, summarizations, and so on, and be able to extract the data that you think is valuable from that data lake tier, and either see it here in the data lake or promote it into analytics, right? To do things like analytic rules and detections. We have, of course, a way to do interactive queries in the data lake using what we call the Lake KQL Explorer, or also the MCP server that David also briefly explained in the architecture platform. And lastly, you can also have Spark. So you can run Spark jobs for those batch, heavy queries and machine learning workloads. And we offer and manage data lake compute with different SKUs that you can use for that job. Cool. Let's talk about data management or table management specifically. Table management basically allows customers to manage data retention settings in analytics and data lake tiers. It allows you also to change a table from one tier to another seamlessly, and we'll see a demo about that. You don't need to change anything on the data collection method. You don't need to change anything on the data parsing. And once the table is switched, the data starts flowing into the new tier after you have changed it. So here we just have continuing with that picture that David showed, we're going to be showing how it works from a conceptual perspective, right? So you're sending your data through the API or through one of the connectors to the signing logs tables in this case, and I can just switch that table to the data lake tier, right? The flow, as you can see, or the pipeline itself continues to be the same, except the last step where the output stream or the output table goes into the data lake tier in this case. By the way, we announced at Ignite that we support now also MDE tables, Defender for Endpoint tables in lake-only mode. So if you want to extend the retention of your MDE tables beyond the 30 days that are the default retention in XDR, you can just do so in the portal. And I'm going to show you a demo of that. And we will support MDO and MDA tables soon. All right, let me bring up the demo. So I'm here in the Defender portal, right? As you know, Defender portal is the home for the Sentinel data lake, and I'm already navigated to a specific part of the interface, which is configuration tables. So in these configuration tables, I see, as I mentioned, all the different tables that I have in my environment. I'm going to look for a specific one, for example, DNS, DNS events, and I can manage the retention settings for this specific table. As you see right now, this table has an analytics retention, so the data is retained in the analytics tier for 90 days, which, as you probably know, is included in the cost of analytics ingestion, and a total retention of 1 year. This means that the difference between 90 days and 1 year, in this case 9 months, will be kept only in the data lake tier. Okay, that's an important thing to mention. I can, of course, change these values to whatever I want I like. But then, as I mentioned, we can just switch this table, DNS events, entirely to the data lake, right? I get a warning whenever I do that. Things like analytic rules, hunting queries, and so on will not work. I will be able to query the data with full KQL, as I mentioned before. And I can just make the switch, right? I'm gonna just click save here. The tier change is gonna happen under the covers, and it's gonna succeed, as you can see, right? The data lake, so the DNS table right now is moved to the data lake. I didn't have to change anything on my data collection. I didn't have to change anything on my parsing. Everything was done under the covers for me. Okay. I'm going to show you also how this behaves for those MDE tables that I mentioned, right? Imagine that we have here device events. It's an MDE table, as you know. So by default, you will see it like this, right? Basically, the analytics retention, it's specified as 30 days. This means that it's still in the XDR tier, okay? It didn't go to Sentinel yet. And you will see this warning, right? Telling you to move XDR data to Sentinel, you have to set the analytics retention to at least 60 days, right? So if I move this to 60 days, this will mean that the data will start flowing into Sentinel, right? In the Sentinel analytics tier in this case. As you can see here, it will move data to Sentinel and incurring analytics and ingestion cost. If I increase this specific value, it will also tell me that the difference between these two will be stored in the data lake, okay, as we just explained before. And again, the cool thing that we announced at Ignite is that now I can just switch this table directly into data lake, meaning that it will stay for 30 days in the XDR space, and then automatically be moved or be streamed into the data lake tier. Okay, cool. Let's go back to the slides. So as you saw in the demo, we can do a table switch, right? We can switch a table from one tier to another. But what if I want to specifically have, I want to have specific records in one tier and other records in the other tier? I can still do so, right? We're gonna show you here conceptually how it would work. Basically, you have the streaming of data, again, with the same pipeline. And then what you can do is in the DCR itself, in the data collection rule, you can specify two data flows, two destinations for the data with a specific condition, right? So in my case, I would say, hey, high fidelity data, I want it to keep going to the analytics tier, to the syslog table. But high volume data that is not so interesting for me for my detections, I want it to be sent directly into the data lake tier with a custom log table, syslog_cl. The schema will be the same, exactly the same between the two tables, but there will be two tables, one's native and one custom log. So how do we do this at a low level, right? So first of all, we have to create a custom log table with the same schema as the source table. I have there a link, we'll put it in the chat, for a table creator script, so a script that can help you create the table with the same schema that you need. And then you need to modify your data collection rule to split the input stream in two separate data flows. One data flow will go into the analytics tier. As you can see in this case, I have selected that the condition for that data to go into analytics tier will be that the device action equals to allow. And then it will go to this specific table in this case. And then a different condition for the data to flow in the data lake tier. Right? In this case, I chose a condition that is the opposite from the previous one. So I get all the data and there's no filtering in this case. All right. Important considerations for data lake ingestion. First of all connectors and tables that use the log ingestion API, that use DCRs, have support for sending the data lake as a whole, right? The data will be mirrored basically into the data lake. Tables that use the legacy API, you might remember the HTTP data collector API, we also call them custom logs v1, do not support data lake, no mirroring and no lake only, right? There's work underway internally in Microsoft and with ISVs to update the connectors that use this method to the new API. And data ingestion for those tables continues to flow normally into the archive tier as it was doing before, so not a problem there. In general, all DCR-based tables support lake-only ingestion with a limit of exceptions. The main use cases for these exceptions are there's Azure Monitor solutions that would break if lake-only allowed is allowed in those tables, like Kubernetes, Container Insights, and so on. And also the diagnostics, the Azure Diagnostics table. We are actively working with the different Azure services to move to resource-specific tables that support lake-only mode. Okay, let's move into on-prem data collection. So first of all, we have to talk about Azure Monitor Agent. Azure Monitor Agent, AMA, is the main tool that our customers use to collect data from Windows servers, from Linux servers, and so on. So we support syslog, we support Ceph collection, and here we have basically a series of different characteristics that define AMA. I'm not going to go through all of them, but important to mention cost efficiency, supporting transformations and filtering, as you can see over here, hardened with different industry standards being supported. Obviously very native to the Azure ecosystem, applying the same ARC policies, RBAC, etc. And allowing also for central configuration and monitoring through the Azure portal. So this is how it works in terms of AMA plus data collection rules, right? I can, for example, define a data collection rule 1 that will effectively apply to a wide group of machines. Some of them might be already in Azure, some others might be still on-prem. And then the data collection rule is telling the servers to provide security events common and send those into the Sentinel workspace, but also performance data to be only flowing to a log analytics workspace that doesn't have Sentinel, right? So as you can see here are the flows that I define, right? Security events going to Sentinel, performance data going to the workspace, to the log analytics workspace. And I can have a separate data collection rule to collect additional data if I want to, right? In this case, I wanted to collect specifically for some servers, maybe SQL servers, for example. I want to specifically collect some Windows events that are very concrete for that kind of role in the server, right? And I can just forward those to Sentinel in the way that you can see in the screen. We wanted to also mention the Logstash method, right? So Logstash, as you probably know, has a rich ecosystem of input, filter, and output plugins that customers can benefit from. So, Microsoft has created its own Sentinel output plugin that is built again and supported by Microsoft. We're planning GA of this plugin in the first half of calendar year 2026. It supports data lake, of course. All the tables that you create or that you send data to using the Logstash plugin are data lake supported. And of course, recommended for those customers that have prior Logstash experience, as Logstash has its own specifications and things that need to be taken into account in terms of sizing and so on. I'm turning over to Suvarna for a couple of slides. Suvarna, you want to take over for the Azure Monitor Pipeline?
Thanks, Javier. So Azure Monitor Pipeline is our solution to facilitate high-scale data ingestion and routing from edge environments to enable observability across cloud, edge, and multi-cloud. It also leverages OpenTelemetry Collector at its very foundations. There are three main scenarios that help you use this Azure Monitor Pipeline. The first one is high-scale data ingestion scenario. So if you have any resources that emit high volumes of data and need to be routed to Azure Monitor, this can ingest high-scale data in the range of millions of events per second without patching additional tools for scaling. The second is observing resources in isolated environments. If you have any resources that are located in isolated network zones without any direct cloud connectivity, Azure Monitor Pipeline and Edge combined with Azure IoT layered network management can help facilitate a connection between Azure and Kubernetes cluster in isolated networks. All you have to do is deploy the Azure Monitor Pipeline at Edge, collect data from resources in segmented networks, and route it to Azure Monitor for comprehensive observability. Last, but definitely not the least, is the intermittent connectivity scenario. If you have any resources that often experience intermittent connectivity, which can eventually lead to potential data loss, you have a caching mechanism to store this data during intermittent connectivity scenarios and prevent data loss. This can also help backfill to the cloud once the connection is restored. Next slide, please. And this is an overview of like how this Azure Monitor Pipeline is actually working. So we're able to ingest into the Azure Monitor Pipeline through direct ingest or any agents. And this is ingested into the Arc-enabled K8s cluster, which is what an Azure Monitor Pipeline is based on. There's also the Azure Monitor Pipeline configuration. There's three main components for that. The first is the listening ports, where it wants the data to be collected from. Second is like the destination DCR and stream, which tells it where exactly does it have to ingest the data into? And the last is a caching configuration, the similar thing that I just mentioned previously in the scenario, where you're able to mention your persistent volume storage for this as well. And this entirely is our Azure Monitor pipeline configuration. This is then passed on to the cloud side, which is where the data collection rules come in. And this is something that we also covered previously in the slide, where this basically mentions the schema of the incoming stream. You can also perform any other transformations before ingesting into log analytics. And this also determines, this also mentions a destination to send the data. And so this is entirely the data collection rule. And this basically sends all the transformed data into Microsoft Sentinel, which can be like log analytics workspace or a data lake.
Perfect. Thank you, Subarna. And turn it over to you, Sagar.
Thank you, Javier. So let me start sharing my screen. All right. So first-party data collection. Okay, so we have approximately around 17 Azure connectors in Content Hub. So most of the Azure services use diagnostic settings to forward the data to Azure Monitor, as explained by Dave earlier in the presentation. And we have a hard limit of 5 destinations here, specifically when you're actually sending the data. So please keep that in mind when you're actually sending data via the diagnostic settings. Intra ID data also uses the diagnostic setting availability, technology, and then you can also send multiple data types within Intra ID into your log analytics workspace. We also cover the Microsoft 365 suite, the Exchange, Teams, and SharePoint, Power BI, Project, Dynamics 365, Power Platform, and Defender XDR tables. We also cover the Purview data ecosystem as well. So we send and we support data connectivity from data sensitivity logs, information protection, and insert risk management, the IRM systems. Coming to 1P asset connectors, this was a new functionality which was introduced along with the Sentinel data lake. So typically, in the original, in the presentation earlier, Dave showed there is an asset store where all of these asset connectors are sending the data typically to. These asset tables actually power a lot of the Sentinel graph experiences which were introduced along with the data lake. For example, hunting graph, blast radius, Purview, DSI, and IRM integrations, and the graphs which are powered inside of DSI and IRM. Typically, these are enabled by default when you actually enable your data lake so that you don't have to turn on the connector. You also have the flexibility to go and turn off these connectors, but please keep in mind that these power a lot of the other experiences within Defender and within Purview. So when you turn these off, that associated functionality would not work. Additionally, when you actually start ingesting this asset data, you incur additional data lake charges. And the duration of the snapshots is typically 24 hours. So every 24 hours, there's a snapshot which actually gets into these asset tables. So these are the tables which are available. So we support currently 3 sources. The Azure Resource Graph, you have resources, resource containers, and authorization resources. Typically, you would need a subscription owner permission to enable the Azure resources for that particular subscription. So any new subscription owner can enable the resources pertaining to that particular subscription. Now, this functionality is in general availability. You can go ahead and use it. Similarly, we have Microsoft Entra ID assets which are supported. You typically don't need any specific permissions in this case. You would need to be a Sentinel contributor, and then everything will work seamlessly. The applications, group memberships, groups, members, organizations, service principals, and users are supported. And then this is in general availability as well. We recently have started a private preview of Microsoft 365 assets, which starts with SharePoint sites and lists. These assets are actually inferred from Microsoft 365 audit data. So you would need the Microsoft 365 audit, which is the Office data connector to be enabled for these assets to be ingested. This is in private preview currently. We are working on making this public preview pretty soon, and then we'll expand the assets from SharePoints to SharePoint Exchange and Teams as well. We also introduced 1P Copilot logs. So this is M365 Copilot logs. This supports basically primarily the observability and governance of AI agents. A lot of audit data is actually flowing through this connector. This was primarily introduced due to the renewed AI push at this time. So, for coverage and monitoring of your AI agents, this connector will help you make sure you get the logs which are generated. This is currently in private preview. We intend to make it generally available in the first quarter of calendar year 26. This is automatically lake only integrated. So if you want this data to be ingested to lake only mode, you can do that. It also supports additional graph enrichments using Microsoft 365 assets. This is something which which is very popular right now with a lot of people asking for it. So going to third-party data collection. So we use the codeless connector framework, as explained by Dave earlier in the presentation, to ingest a lot of the third-party data. Now, there are some core components of the CCF, such as the polling as a service infrastructure, which is fully managed and supported by Microsoft, unlike the Azure Functions one, where the customers would have to deploy the Azure Functions to kind of turn on the connector. There is no requirement for any service installations. No coding required. It's just a configuration submission, which you need to provide for the connector to work. It provides built-in health monitoring, which I'll show in a bit. And there is no additional cost to actually set up the connector. Only the ingestion costs apply, unlike the Azure Azure Functions connector. So, and these all the connectors built on top of codeless connector platforms are scalable and performant as well. So it supports various different sources. Typically, the most popular one is pulling the data from the REST API endpoints. So we have different authentication models and pagination types, which are supported and handled. You can also pull data from AWS S3 buckets. You can also pull data from GCP PubSub. You can pull data from Azure Blobs. And there is also an additional functionality where you can also push the data into your workspace using codeless connector framework. The blob and API push are currently in private preview. These will be made generally available in the new year, where it will be available for all customers to be used. Again, the pipeline pretty much remains the same as explained by Javier earlier. So you have a data collection rule, you specify what data to collect, you specify the schema of the incoming stream, you specify the transformation, what data do you want to filter. If you want to manipulate any data, you specify the transformation there, and then the destination where you would like to send the data. So specify all of that, configure all of that in the DCR, and then the data starts showing up in your Microsoft Sentinel workspace. And then using the table management, once the connector is enabled, you can decide where you want to send the data to. If you want to send to analytics or data lake or both, you can configure your table management accordingly. Now, as I explained, we have several CCF types. So for the REST API ones, we typically pull it from the third-party hosted APIs. It supports 10 plus auth models, including basic API key, OAuth2, and JWT. There are several others. We also support 5 plus polling and pagination types. We support the ingestion from S3 buckets. There are 13 native connectors included as part of the connector ecosystem, including CloudTrail, GuardDuty, VPC Flow Logs, CloudWatch, etc. You can also do custom ingestion from any CSV or JSON file, which are present in AWS S3 buckets using CCF. You can also use the GCP PubSub. We have 12 native connectors today from the GCP ecosystem. And you can also do a custom ingestion here as well. As for the Azure blob, so you can ingest files located in any Azure Storage blob container. Some of these are used by the out-of-box connectors, for example, like GitHub. And then finally, API push. So you need to create and handle a service principal and a secret created in Entra ID. You need to configure your third-party app with the credentials, and then the third-party app pushes the content or the data into the Sentinel very seamlessly. So that's the API push functionality, which is currently in private preview. So there are some advanced CCF features which we have built in the last year or so. So we have direct ingestion from storage blob. So a sample connector like that, which we built, is for Cloudflare. We also support nested APIs. So Salesforce Service Cloud connector works on this technology. We are rapidly expanding multi-API endpoint support. So we have Cisco Meraki, Salesforce for multiple domains. So a lot of these connectors will start coming in with the capability to support multiple API endpoints in multiple domains. WebSocket support is supported using supported in the Oracle Cloud Infrastructure Connector. You can now also make connectors multi-instance. One of such connectors is Okta. We will rapidly expand this capability as well to other connectors where there are requirements around multi-instance. And CCF push, one connector which we built along with our ISV providers is Jamf, where the required secret and ID is configured to kind of push the data into the Sentinel workspace directly. This is an eye chart, but approximately 350 plus out-of-box connectors available. So you can go to aka.ms/sentinel connectors to get a list of all the connectors supported today in Microsoft Sentinel. So there are different categories for connectors. So please explore those. One core thing again for CCF, it comes with out-of-box health monitoring. So all the health data which is generated by these connectors go to Sentinel Health Table, which can be queried, and then you can set up your own dashboards on top of it. You can also set up your DCR health monitoring in case you're creating your own connectors. There is configurations and diagnostic settings which you can enable to send this data to your particular workspace as well. So this is how you do it. You basically send the data for a particular log analytics workspace in a table, and then that starts to show up in your workspace as well. So finally, a little bit about normalization. So the Sentinel normalization technology is ASM, so it is finally GA now. And we intend to renew our investment in ASM schemas. We are planning to introduce additional schemas. We'll start with email. We will also introduce more parsers, starting with Azure Firewall and VNet. And then you will start seeing more and more ASM schemas coming in. Another recent delivery and capability which we have enabled is that ASM tables can now be switched to data lake. If your ASM tables have a lot of data which you don't want to use it in analytics, you can do that. Couple of caveats: if you do switch your ASM tables to data lake, your KQL functions would not work. So those are some of the capabilities which we are trying to add in the data lake, which is not available currently. And if your ASM function refers to a table which is already in a data lake, that data would not be showing in the results. So there are a couple of caveats that you need to keep in mind in case you are switching or using ASM against the data lake. So finally, summary. So please connect your Sentinel workspace to Defender. It opens up a lot of new capability which we have built and delivered. You will be able to take advantage of the data lake. It comes with Graph, MCP tools, all the AI technologies along with it. So all the great features are enabled on top of the lake. You can find all of our connectors at aka.ms/sentinel connectors. You can go to aka.ms/create CCF connectors to learn about how to create a codeless connector yourself. You can also go to aka.ms/sentinel what's new, which is our Sentinel blog, which describes the new functionality which we have been releasing in Microsoft Sentinel pretty recently. And also, please join our connected communities, join CCP. Any new private previews are rolled out using our connected communities. You would get to test, experiment, provide feedback, use that functionality using our connected communities. So we encourage you to join our connected communities as well. So that kind of brings me to the end of the session. So we can probably answer a few questions, maybe.
Sure. Do we see any in the chat? I don't see really in the chat. If anyone would like to ask their question, a moderator to ask their question now, you can post it to the chat. Oh, there are a few. Looks like Javier answered most.
I see one. I'm going to read it live and see if we can answer. So using a summary rule to summarize the common security log table in data lake and then sending it back to analytics. This takes one of the available KQL jobs. We are using them. Now, if I want to add async DNS, yeah, so basically this is a follow-up question, follow-up answer to a question where they were asking for higher KQL job concurrency limit. So yeah, interesting to see that your use case and a scenario. We'll take a look at that and feel free to contact directly to us via the CCP community. Yeah, and we can talk about the specific concurrency limits that we'll have in the future.
Okay. I think that is all we have. So thank you, Sagar, Javier, and David for being our guests today. And thank you for sharing the great information with our community. Also, thank you to anyone else who helped with answering questions and providing the resource information. To all listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/security-community. This is also where you'll be notified about the upcoming webinars, events, and other announcements. For those of you who may have additional questions on the topic we just covered or other product-related questions, please feel free to raise on our Microsoft Tech Community discussion page at aka.ms/Microsoft Sentinel Community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.